Welcome to qnawire.
Hi, so over here we're told that the pressure in Venus is equal to 1350 psi, and we know that the surface temperature is going to be equal to 467 degrees Celsius. We are told that with this information, for 1 mole of a gas at a volume equal to 1 liter, what is going to be the value for R? So in this case, first of all, we need to convert the pressure from psi into atmospheres. We know that 1 psi is going to be equal to 0.068 atmospheres. So the result that we would get would be equal to 91.8 atmospheres. And the temperature in Kelvin, we simply need to add the value of 273. So 467 degrees Celsius would correspond to 740 Kelvin. With this information, to get the value for R, we're going to assume that we are going to be able to employ the ideal gas equation, PV is equal to nRT. Thus, the value for R would be equal to PV divided by NT. The pressure is 91.8 atmospheres. The volume that we're going to get is 1 liter. We have 1 mole and divided by 740 Kelvin. Remember that we need to express our units in terms of Kelvin, since this is going to be the thermodynamic temperature. So the value for R in Venus would be equal to 0.12405 liter atmosphere over mole Kelvin. And this would be our value. Now, using this value for R for this first part of the question, we want to calculate in part 2 what is the mass of 2.25 liters of oxygen on Venus. On Venus at 325 degrees Celsius and 83 atmospheres. So in order to do so, we're going to remember that mass is going to be equal to the number of mole multiplied by the molecular weight of the compound. In this case, the number of mole can be given from ideal gas equation from this part over here. So the amount of mole would be equal to PV divided by RT, and the molecular weight corresponding for oxygen. So in this case, we have 83 atmospheres, 2.25 liters, divided by the value for R, 0.12405 liter atmosphere over mole Kelvin, times the temperature of 325 degrees Celsius, which is going to be equal to 598 Kelvin. So with this, we can verify that everything cancels out, Kelvin and Kelvin, and the units of this first part is going to be equal to mole, and then multiply by the molecular weight of oxygen, which is going to be 32 grams per mole. In this case, now the mole is going to cancel with 1 over mole over here, and we will get our result directly in grams. So the mass is going to be, rounding up to 4 significant figures, it would be equal to 80.56 grams of oxygen. If you want, you can plug in the full value. That would be 80.558.73468. But in this case, this would be more than enough. And finally, for part 3, we're going to have 5 mole of an ideal gas at the surface of Venus. That means that the temperature is going to be equal to the temperature of the surface, which we calculated as 740 Kelvin. And the pressure would be that of the surface of 91.8 atmospheres. And we want, just the pressure is going to be 91.8. The temperature would be 25 degrees Celsius. So at 25 degrees Celsius, this would be equal to 298 Kelvin. So the volume, applying ideal gas law, would be equal to nRT divided by the pressure. We have 5 mole The value for R that we calculated, 0.12405 liter atmosphere per mole Kelvin, times the temperature, 298 Kelvin, divided by 91.8 atmospheres. Notice that now our result is going to be in liters and would be equal to, right, verifying, equal to 2.02 liters. And with that, it would be all. Thank you very much and have a good one.